Number 44, like at some point I'll show you how to do this using a formula, but for now we're just going to do it by hand. What I mean is we're going to write out what this means, what this summation problem stands for. And so look, if n is 1, this is a tenth. Well, 5 times a tenth is 5 tenths, which I'm going to write as decimal. Plus, and let me say again, the summation means you're adding up the terms of the sequence. So next is, n is 2, you get 100th, so it's 5 hundredths. Plus, and then it's 3 is 1,000, so 5 thousandths, and then you get the picture. 5 ten thousandths, and so forth, okay? By the way, this is called a series. A sequence is just a list of numbers. A series is the numbers added. That's the only difference. But this is technically called a series. So the answer then is 0.5 repeating. Which, by the way, is equivalent to 5/9. I'll take it in any one of these forms. But I do want you to know that 1/9 is 0.1 repeating. So 0.5 repeating is so many nines, 0.7 repeating, so many nines, and so forth. Okay? Any other questions about the homework? The 10-1 bookwork. Okay, then let's get into the new stuff. And listen, I gave you the foldable. Let me kind of explain how it works. Now, I need you to write this down in your notes. Where it says the nth term formula, where it says an, put this. Let's get on the left side. I guess the second box, which says an. Put the explicit formula, also the nth term formula. And I would label it with the term explicit formula. If you turn the flap over, you can see it calls it the nth term formula. And when you hear those terms, the point is, this is the formula that it'll give you whichever term you want when you give it the term number. I want you to put the recursive formula back in the top box. So in other words, here, I'll come back to that. What you'll have is, the nth term that you just wrote down, and above it, you already had the common difference, which you just found the common difference by subtracting two terms. Well, the recursive formula, so fit this in, the recursive formula is the same thing, just restated. So this said, if you subtract any two terms, you should get a constant that we call the common difference. But if you rearrange that, you find that, therefore, to find the nth term, you would add some constant to the previous term. Now, the recursive formula, you need to have a starting value, so that's your complete recursive formula. But I'm saying the recursive part of it is just the definition of the arithmetic, just rearranged. You subtract any terms, you get a constant, which in other words is saying, define any term, you add some constant to the previous term. Okay? And this, the explicit formula that I wrote down here, I actually kind of like having it like this, but it doesn't matter. You already wrote this one down. That one, once again, is, it's more useful, frankly, because if you want the millionth term, just plug in a million, it'll give you the millionth term. Whereas this one, if you want the millionth term, you have to find all million terms, one after another. So the recursive formula is not that useful, except it describes very well what the sequence is doing. All right, so you should be able to state the recursive formula, because it should be obvious. You should be able to see what how the sequence behaves. I think you got everything on there. So look at this one. Write this down, in fact. No, we're going to do it. Getting people time to get paper out. Go ahead and so. All right, let's get through this. So it wants the nth term formula or the explicit formula. I'm going to write the actual formula down first. And like you can put the D before or after. Let me explain this first. Let's explain this a little bit. By the way, what is happening to get it from terms of decreasing by 11, right? So D is negative 11, fine. If I kept going, if I decrease by 11, I get negative 19. Decrease by 11, I get negative 30. Decrease by 11, I get negative 41. Which term is this, by the way? The negative 41? Right? Sixth term? So, look, watch. If I wanted to calculate the sixth term, then according to this formula, I would start with, here, let me write the formula out first. The first term is 14. The common difference is negative 11, so it's minus 11 times n minus 1. So that's the answer to the first question. What is this explicit formula? That. So find the starting value, right, find the common difference, you have your formula, all right? And the purpose of that formula is to find whichever term you want. So what I'm trying to explain is if I wanted to find the sixth term, I would start with a 14, and I would reduce it by 11 how many times? How many times did I subtract 11 to get from the first term to the sixth term? 5 times, yes? Which is why it says n minus 1 right there. So that's why this is structured the way it is. To get from the first term to whichever term you want to, you add or subtract the common difference n minus 1 times, because that's how many jumps there are between the first and nth term. Okay? When we do the geometric, it's going to be the same principle of having n minus 1 in it for the same reason. Okay? Yes, Eddie? No. N would be 8, but you'd have a 7 here. You just got to be careful how you say it. But yes, that'd be a 7 there. Because you make 7 jumps to get to the 8th term. Yes. All right, now the recursive formula, and I would label it. Recursive formula should be easy. There's 2 parts always. You need to know the first term, which is the 14. And then the actual recursive formula tells you how to get to the nth term from the previous term. Well, how did we get to each term from the previous term? And there you go. Isn't that what we did? That's what I'm saying. The recursive formula, it's not as useful. Let's see. Okay. Well, it's very useful for generating the sequence, but it's not useful for finding any random term, because you can't. You have to find use it to generate the whole sequence up to that term. Unlike this one, where you can find whichever term you want just by plugging in the term number. But this describes what's really happening. You start with 14, we decrease by 11. So that's something you should be able to write the recursive formula usually just by looking at what the sequence is doing. All right, another one. Write this one down. You do this one actually. And if you look up here and check your work, obviously in the first one part you just plug into the formula. And the second part should be self-evident. You start with 15 and you increase by 18 every time. Yes. Because, and listen, and I'm glad you brought that up, because if I just said generate a sequence where you just increase each term by 18, you have to have some starting number, because you can find all sorts of different sequences that follow that pattern, right? So yeah, with recursion, you have to have both parts. What do you start with, and then how do you generate the sequence from that? Okay? And so, if it's a test question, ask for the recursion formula. You don't give both parts, well, I can't give you credit, because it's not full credit. All right, write this one down. A little different situation. Not a terrible stretch. You could do that, but then you'll never finish the test. So no. We're going to use the formula, okay? First of all, by the way, what is D? It's a good idea to write that down. You don't have to, but it's a good idea. I'm going to, look, we basically have, let me say something. Let me just write out the formula. And so the nth term formula is 11 minus 7 times n minus 1, right? But the whole purpose of this formula is to give whichever term you want. So if you want to find the 41st term, you do 11 minus 7 times what? 40. And then do the math. That's 280. When you subtract, you get negative 2 something. That is correct. And we're done. Okay? Now listen, I'm serious. You're going to have all these formulas floating around, and you need to keep them straight. So watch this. If I wrote this notation, what does this represent? The S stands for sum. The sum of what? The first 41 terms. The first two 41st terms, including the 41st, okay? What does A41 represent? The 41st term, that single term, right? And I've had people ask, so does this represent the sum of the 41st term? Which doesn't really make sense to me. You know, it's the sum of the first 41 terms. You know, so it's not hard. I'm just saying, keep the notation straight. Be clear what we're talking about. Keep the formulas straight. And by the way, you need to know these formulas, memorize these formulas. And that's why I stress understanding them, because if you just memorizing them, you'll get them all confused. You won't understand your mistakes. So get them. We're going to skip that one. Sorry, let's move on. So write this one down. This one's kind of backwards, because they gave us the 44th term. So I'm going to set up my formula again. And this is one of those situations where you're going to plug everything into the formula and solve for missing parts. So where does the 229 go? Archem? We're going to put the 229. You're fine. Yeah, it's the answer essentially, yes. We're going to put the 44. It does. It's the term number, which means it's n. Okay? And once again, to get to the 44th term, we'd be jumping 43 times. And I think I'm going to put the 8 in place of D. And by the way, if I just put A, I mean A1, the first term. We don't always put the subscript. And so now you solve for the first term. So this is really 43 times 8. What is 43 times 8? 344. And then subtract the 229 from that. I'll let you do that. And subtract, subtract, subtract. That's correct, except for one thing. Yeah, I was supposed to be subtracting 344 from 229. I didn't set it up that way because you always set up subtraction, this way, but remember it is a negative. And we're done, right? Because it said find the first term, and that's what this represents. Okay. Red eye? Ready? All right. Look at this. I just want to explain, you don't have to write this down. There's a lot there. But the reason an arithmetic sequence is called an arithmetic sequence is because every term is the arithmetic mean of the term before and after it. So look at this. If you add 3 plus 9, you get 12 divided by 2 is a 6. That's arithmetic mean. You add up and divide by n. And so if you add up the numbers before and after the 9, you get 18 divided by 2 is a 9. If you add up 9 and 15, you get 24. Half of 24 is 12. So that's always true on an arithmetic sequence. Okay? A geometric sequence is so called because that same principle holds down to the geometric mean, which you may not know what that is, although they teach us in geometry now, the geometric mean, but still you may have forgotten. All right. I don't know why they chose problems with decimals, but we'll be okay. It's not that bad, actually. Now, write this down, first of all. And once you've written the problem, I want you to kind of lay it out. We're going to presume that they mean that 612 is the first term, And when it says it has 5 arithmetic means between those two terms, this means there's 5 terms, 5 missing terms. That's all they're really asking is lay it out like this and figure out the, fill in the blanks. So they could ask the same question different ways without calling them their arithmetic means. Really, I'm just going to do slope, essentially. In other words, I'm going to do the last value minus the first value. And you can figure this out without doing a formula. So I do this one minus that one, I get a negative 7.8. Or in other words, to get from here to here, I decrease by 7.8. You don't need a formula to tell you that. And then what goes here? Delta x. Which term is this, by the way? Count it out. Yeah, 1, 2, 3, 4, 5, 6, 7. And this is the first term. So that was 6 jumps, yes? And if you do the division, that works out to negative 1.3. Which means we're decreasing by 1.3 every time. So what's the second term? Take away 1, you have 5.2. Take away 0.3, you have 4.9. Minus another 1.3 is, I don't know, 3.6. Minus 1.3 is that. Minus 1.3 is that. Minus 1.3 is what? Negative 0.3. And then minus 1.3 is that, which means we were right. Yes, sir. I'm just saying, look, slope formula is y2 minus y1 over x2 minus x1. So I called this y2 and that y1. And this is the 7th term, and that was the first term. So I just subtract the term numbers. So the term numbers are like your x values. And the term values are like your y values. Okay? All right. We're going to skip to this one now. You saw this in geometry, but that was a little while ago. I don't think they revisit this in Algebra 2, but I could be wrong. I'll come right back to this. Let me go back to some of these. Look at this one, for instance. I've been saying this is an arithmetic sequence, and it is, because it has a common difference of 10, yes? If you graph this thing, it would be a line, okay? And so we're looking at these, they're really linear equations. I'm saying, watch this. If you wanted to find the rule for this equation in Algebra 1, you would make what's called a finite difference table. And I'm going to skip. Well, I guess I can't skip. Okay, I'm going to mess up entirely. Let me put 1, 2, 3 here, because that's the term numbers. And then the terms themselves go over here. So you didn't see all that came before. And then you say, oh, that goes up by 10, goes up by 10. They have the common difference, so therefore it's a linear equation. What's my coefficient? 10. Where you do 10 over 1 to get the 10, but it's 10. And 10 times 1, 10 times 2, 10 times 3. And then, like here, that's 10. How do you get a negative 3 from 10? Minus 13. This is 20. 20 minus 13 works out. That's 30. Can't read it, but it's 30. 30 minus 13 is 17. So my rule is 10n minus 13. Okay? We weren't doing it that way. We're saying that you start with the first term, and you're adding 10 every time, so plus 10 times n minus 1. And frankly, if you simplify this, though, you'd get this. I'll take you to form. Okay? It's kind of an algebraic simplified way to do it. Or you can leave it like this so you can see the first term and the common difference. We're doing all that because for these, we're really just going to do it the old way. And so I'm going to make a finite difference table. Instead of x and y, we'll call it n and an. So your term numbers go over here, and then your term values, actual terms in other words, go over here. And that's all you need is 4. And start doing your differences. That's 5, then it goes up by 7, then it goes up by 9. The fact that these are not the same means it's not linear, right? If you got one more level, though, you find that it is a constant difference. If I added one more, if I put 32 here, that was an 11, and that, you can see it's just going by 2's. If you've got 2 levels and you get a constant, you know it's quadratic. If you've gone out 3 levels and it works out to be constant, you know it's cubic. 4 levels will be quartic, and so forth. Okay? Now, here's where things differ. What I'm saying is, like here, I know my rule is going to have n squared in it, so you take your n values and square them. Okay? And the coefficient, though, this time isn't this, it's half of that. So you don't use the 2, use half of the 2, which means the coefficient is 1. So I know at this point that my rule, let me start my rule, it's going to be n squared, just 1 n squared. Then I don't know the rest of it yet. Okay? Now, to figure out the rest of the rule, first you say, okay, let me start here. This works out to 16, yes? 1 times 4 squared is 16? Yes? Okay, good. You're with me. But it's not, it's supposed to be 21, so put a plus 5. This is 9, but it's supposed to be 12, so put a plus 3. 4 plus 1 is 5. 1 minus 1 is 0. Unfortunately, these are not the same. If it was like all plus 3, you'd say, oh, it's n squared plus 3, you'd be done. But we're not done. We're going to start over. By that I mean, make a new table, and we want to find a rule that's going to, use the same term numbers, but it's going to generate that sequence of numbers. The negative 1, 1, 3, 5. The good thing is this is a linear sequence. We know that because it's just going up by 2 every time. And then if it's linear, then you just use that coefficient. Technically you do divided by 1, but 2 divided by 1 is 2. And then what do you do every time? 4 minus 3 is 1, 6 minus 3 is 3, 8 minus 3 is 5. Which means the rest of the rule is 2n minus 3. So put plus 2n minus 3. So, how do you identify quadratic? The second difference is constant. And then, worst case scenario, it would take 2 steps like that to actually find the complete rule. Here, you try this one. I think we have time. So, here, let me explain that again, if I can. No. Okay. That's too small. All right, I'm try this again. So, like I said, first, common difference in the common difference again, since it's second level is constant, I took half of the time coefficient, so I knew this part of the rule. Then I said, okay, if I plugged in 1 of this, it should produce a 10, but if I plug in 1, I actually get a 2, which means it's plus 8, so I put an 8 there. For the second term, I plug in 2, I get 4 times 2 is 8, so this produces an 8, but plus 6 is supposed to be 14, so that's where I got the 6 from. And when I plug in 3, it's supposed to produce 22, but 3 squared is 9, times 2 is 18, and 18 plus 4 is 22, so that's where I get this list. And then I do the rule, and it's decreasing by 2 every time, right? So I put a minus 2, and I mean. And then it's supposed to produce, when you plug in 1, it's supposed to produce an 8, but it produces negative 2. So plus 10 is what makes it work. And check at least one more. If you plug in negative 2, you get negative 4. Negative 4 plus 10 is 6, so there's the rest of the rule with less work in the paper. So show the work either way. With all the tables, it helps you keep track of stuff, or not. Okay? Same process either way. All right, so totally different. Write down just the first formula for now on your green sheet. And by the way, the bottom left box on the green sheet, bottom left, trash it out. There is no such formula for arithmetic. So where it says sum of a finite sequence, that's where we put in this. You know, second from the bottom on the left side is where this goes. And this is another version of it, which frankly I'm not in the habit of using. So I'm not going to have you write it down because I probably won't even use it. But you can try it out if you want to. By the way, you've already written it down that way, it's fine. Another way to write it is here, watch. Because I want you to, I guess you have to memorize this stuff. And so it helps if you get it or have a better way of interpreting. What I'm getting at is if I wrote this, you see that this represents the arithmetic mean, the average of the first and last term? Yes? So this formula is really just n times the average of the first and last term. And you can put it in various ways. You can put the n by itself out in front. You could also just put it as part of the numerator. So the n and that sum are all part of the numerator, and the 2 is in the denominator. And like I said, there's a few different ways you could arrange it. The way they wrote it is fine. The way I just wrote it is fine, whichever you prefer. Okay? But like I said, remembering it's really just to average first and last term times n helps you memorize it. All right. Write this down. Here's the formula we need to use. Well, let's see, you can call this A1 or just A. By that I mean the first term. So let's see. We know the first term. We know the last term, the nth term. We know the 2. But we do not know how many terms there are. So I need to go back and figure that out. So I'm going to use our nth term formula. Let's write it out first. So what goes here? The 157, yeah, good. And the first term is the negative 3, I know that. The common difference is what? And then just solve for n. I'll start by adding 3 to both sides. We're going to divide by 5. You get 32. By the way, just for the record, a quick way to divide by 5 is actually double and then divide by 10. Because 160 doubled is 320, divided by 10 is 32. Or it can be divided by 5. And then n is not 32, it's 33 in fact, right? Please don't make the mistake. I think it happens all the time, frankly. People just use 32. No, 33. So that goes here. So it turns out we're actually finding the sum of the first 33 terms. That was the 33rd term, so that's the sum we're finding. Now, first I would add this first. That's 154, right? And then, how many times does 2 go into 154? Here, I'll do that. 70 what? Yeah. So now you have to sit down and do, 77 times 33. I'll let you do that. Find that product and we'll be done. And just for the record, in the last test, quite often the problems people had was with arithmetic. So do the arithmetic. And I'm saying they lost a letter grade or 2 because of the arithmetic. Seven what? I think something went wrong. The last digit should be 1 for sure. 2000 what? Yeah. Okay. I think we'll just stop there. That's a good place to stop for today. It's enough.